The cost function C in thousands of dollars for manufacturing X Chevy Cavaliers per hour was found to be the following function. Notice that this is a cubic function, so it's a polynomial function. Specifically, it's a cubic function. Part A, we want to find the average cost function. So remember, to find the average cost, we just divide by the number of items produced. So it's helpful to keep in mind here that X is the number of Chevy Cavaliers produced per hour. Therefore, to compute the average cost function, denoted by C bar, we're just going to take our total cost function and divide it by the number of Chevy Cavaliers we're producing, which is going to be X. So that means our average cost function will be 0.2 x cubed minus 2.3 x squared plus 14.3 x plus 10.2 all divided by x. That's our average cost function. And it's important to notice that we started with a cost function here that was a polynomial, but now the function that we have here, this is a rational function. It's a rational function because it's a polynomial divided by another polynomial. Part B, how many Cavaliers should be produced per hour in order to minimize the average cost? So how many Cavaliers, we're looking for the variable x here. Since x was the number of Cavaliers, we're solving for x, but we want the average cost to be a minimum, and this is a calculator question. So right now, I'd encourage you to pause the video and see if you can correctly put the average cost function into your calculator, and then we're going to try to calculate the minimum. Now, hopefully you successfully got that in your calculator and you can see part of the graph on a standard viewing window. If you're having some issues, you might consider, if you're on a TI-83, for example, it would be important to remember that you include parentheses around the entire numerator and the entire denominator. In this case, no need for parentheses in the denominator since it's just one term. If you're on a TI-84, make sure you use that fraction shortcut button so that way you can enter your fraction vertically, just how I have it written here. And a standard viewing window, remember, will be found on that zoom button. You would choose zoom, and number 6 is zoom standard, which will take you from -10 to +10 in both directions. Now, on a standard viewing window, you should see part of the left-hand side of this function, which we will kind of ignore because x cannot be a negative value here. We can't produce a negative number of Chevy Cavaliers. And on the right-hand side, you should start to see just the bottom. You can see kind of over here like this. That's what my screen kind of looks like when I'm looking at my graphing calculator on a standard viewing window. I see just this little bottom part of this, of the right-hand part or piece of my function. And we want to calculate the minimum, so we definitely want to calculate this min. However, if you go ahead and go to calc min right now, you'll notice that when you go to calc min, and just a reminder again where that is on your calculator, that is located when you find your trace button. Above the trace button, you'll see the letters C-A-L-C, calc, and then you will go ahead and choose number 3 for minimum. But when you calculate a minimum right now, you'll notice that you'll have some numbers and variables at the top of your calculator screen up here, and it's kind of difficult to see this minimum that you're calculating because you have the function up there. So I would recommend instead changing your window. So go to window, and I would alter your y maximum. I would choose a larger number than 10. So for example, maybe I choose a y maximum of 20, just so that I can see that portion of the graph that contains the minimum more clearly. And then go ahead and calculate the min. So in doing so, here's what your minimum should be. The minimum that your calculator gives should be 6.38 if you round to 2 decimals for the x value, and then 9.37 approximately for the y value. Now remember, this is the x value and the y value on the calculator, but we were graphing average cost. So 6.38 is my x value, but 9.37 is my average cost value. So to answer part B, how many Cavaliers should be produced per hour to minimize the average cost? Well, it would be 6.38 Cavaliers. Now, you can't manufacture part of a Cavalier, so you might want to go one step further and actually look at the average cost to produce 6 Cavaliers versus the average cost to produce 7 Cavaliers, since we can't produce a portion of a Cavalier. And you could do this utilizing your table on your calculator. So you could go ahead and take a look at the cost for 6, which comes out to 9.4, versus the average cost for 7, which is the decimal 9.4571, it looks like. So that you clearly see that it is definitely going to cost you less to produce 6. So our answer for part B is that they should produce 6 Cavaliers in order to minimize the cost. Now part C asks for the actual minimum average cost. So we had a Y value here of 9.37, but we said, well, you can't really produce 6.38 Cavaliers. So then we would not answer with the 9.37, but rather what was that average cost when we produced exactly 6 Cavaliers? And we said earlier that that was 9.4. We got that value from the table on our calculator by substituting in 6 for x into our average cost function. But then you also need to remember that your cost up here was measured in thousands of dollars. So this isn't $9.4, but $9.4 thousand, meaning $9,400 is actually your average cost per boat, the minimum average cost per boat.